Graph h of x equals the cube root of x plus 6. Compare the graph to the graph of f of x equals the cube root of x. Begin with the graph of f of x equals the cube root of x. Then make a table of values. Substituting -8 for x in the function h gives h of x equals 4. Similarly, when x equals -1, h of x equals 5. When x equals 0, h of x equals 6. When x equals 1, h of x equals 7. And when x equals 8, h of x equals 8. So plot the ordered pairs -8, 4, -1, 5, 0, 6, 1, 7, and 8, 8. Then draw a smooth curve through the points. The graph of h is a translation 6 units up of the graph of f. Graph g of x equals negative the cube root of the quantity x plus 4. Compare the graph to the graph of f of x equals the cube root of x. Begin with the graph of f of x equals the cube root of x. Then make a table of values. Substituting -12 for x in the function g gives g of x equals 2. Similarly, when x equals -5, g of x equals 1. When x equals -4, g of x equals 0. When x equals -3, g of x equals -1. And when x equals 4, g of x equals -2. So plot the ordered pairs -12, 2, -5, 1, -4, 0, -3, -1, and 4, -2. Then draw a smooth curve through the points. The graph of g is a translation 4 units left and a reflection in the x-axis of the graph of f. Let h of x equal 3 times the cube root of the quantity x plus 1 minus 2. Part A. Describe the transformations from the graph of f of x equals the cube root of x to the graph of h. Step 1. Translate the graph of f horizontally 1 unit left to get the graph of t of x equals the cube root of the quantity x plus 1. Step 2. Stretch the graph of t vertically by a factor of 3 to get the graph of g of x equals 3 times the cube root of the quantity x plus 1. Step 3. Translate the graph of g vertically 2 units down to get the graph of h of x equals 3 times the cube root of the quantity x plus 1 minus 2. Part B. Graph h. Begin by making a table of values. Substituting -9 for x in the function h gives h of x equals -8. Similarly, when x equals -2, h of x equals -5. When x equals -1, h of x equals -2. When x equals 0, h of x equals 1. And when x equals 7, h of x equals 4. So plot the ordered pairs -9, -8, -2, -5, -1, -2, 0, 1, and 7, 4. Then draw a smooth curve through the points. The graph of cube root function m is shown. Compare the average rate of change of m to the average rate of change of h of x equals the cube root of 2x over the interval x equals 0 to x equals 8. Use points whose x-coordinates are 0 and 8. First, find the average rate of change of function m. From the graph, you can see that when x equals 0, y is approximately 0, and when x equals 8, y is approximately 8. So use the points 0, 0, and 8, 8. The average rate of change of function m over the interval x equals 0 to x equals 8 is given by the quantity m of 8 minus m of 0 divided by the quantity 8 minus 0. Substituting 8 for m of 8 and 0 for m of 0 simplifies the expression to the quantity 8 minus 0 divided by 8, or 1. Next, find the average rate of change of function h. Evaluate h when x equals 0 and x equals 8. Substituting 0 for x in the function h gives h of 0 equals the cube root of the quantity 2 times 0, which simplifies to the cube root of 0, or 0. Substituting 8 for x in the function h gives h of 8 equals the cube root of the quantity 2 times 8, which simplifies to 2 times the cube root of 2, or approximately 2 52/100ths. So use the points 0, 0, and 8, 2 times the cube root of 2. The average rate of change of the function h over the interval x equals 0 to x equals 8 is given by the quantity h of 8 minus h of 0 divided by the quantity 8 minus 0. Substituting 2 times the cube root of 2 for h of 8 and 0 for h of 0 simplifies the expression to the quantity 2 times the cube root of 2 minus 0 divided by 8, or approximately 32/100ths. So the average rate of change of m is about 1 divided by the quantity the cube root of 2 divided by 4, or approximately 3 2/10 times greater than the average rate of change of h over the interval x equals 0 to x equals 8. A regular dodecahedron is a solid with 12 regular pentagons as faces. The length s in feet of an edge in a regular solid can be modeled by the function s equals the cube root of the quantity v divided by 7 66/100ths, where V is the volume in cubic feet of the solid. Use a graphing calculator to graph the function. Estimate the volume of a regular dodecahedron with an edge length of 2 feet. First enter y1 equals the cube root of the quantity V divided by 7 66/100ths, and y2 equals 2 into your calculator and graph the equations. Make sure to choose a viewing window that shows the point where the graphs intersect. Use the intersect feature to find the x-coordinate of the intersection point. The two graphs intersect at about 61, 2, so the volume is about 61 cubic feet.